Okay, you can start whenever you want.
All right, so I chose to do my presentation on logistic regression. So the lessons that I'm about to cover are by Depa, and I'm making a few assumptions in the fact that we've all taken regression, or at least understand what basic simple linear regression and multiple linear regression are. And so when I go into this, that's kind of the understanding that I have. So like I said, I took most of this from his notes, so 90% of it will be from that. So like, as I said, it's about logistic regression. So this is part of the models, or they're part of the generalized linear model. So basically, what this model is for, it's used to solve a problem where you're looking for a binary outcome. So that's a true or a false here. So that's the important thing for the response variable. Like I said, in simple linear regression or multiple linear regression, you have your response variable that it doesn't matter necessarily what the response, the outcome of it is. Your number can be anything where this needs to fit in the category of a zero, between 0 and 1. So that's an important thing. So the picture I put up is for failures or success, so we're going to kind of have that as a background knowledge. So you have to understand that it's going to be one of two outcomes. It'll be between 0 and 1. So as an example, in his notes we have Titanic example. This will just be kind of a baseline to help for the understanding purposes. So as I go through the presentation, we'll be using the Titanic, so just kind of keep that in the back of your mind. So the important variables here are the response variable. Everyone understands or knows what the Titanic is. Heard the movie, know what happened there. So the response variable is survived or not survived. So that's the important thing we're looking for to see who on the Titanic survived. And what we're using to understand that would be the gender, age, whether or not they were traveling alone, and then how much they paid for their ticket. So then we'll start with some simple explanations here. So the logit function, this is very important for logistic regression because this is how we are able to hold to the principle of it ending up with a response variable between 0 and 1. So that is the natural logarithm here on the left side. So as you can see, it ensures that at the end the predicted probability will be between 0 and 1. So that's obviously the base requirement for this model here. And it's called the logit function. It's, like I said, it's simply the natural logarithm. It basically just says, here are odds of success. And inversely, like, here are the odds of failure. So the model itself is an example of a nonlinear regression. So how it works is the actual parameters are in the exponential function. I did not put a picture of it up here just because it's a super long, in-depth model that I'm not exactly sure how to explain, so well. Like I said, it's very similar to simple linear and multiple linear regression, as you have to pick your predictors and the terms that'll be able to explain what your success conditions are. So you'll have to go through and you'll pick the best model. So you'll have to look at if you need to, log some of your variables, what you need to change, transformations, things of that nature. It's very similar in that fashion. The only difference, like I said, is whether or not it will be your response will be between 0 and 1. So interpretation is a little different. The important thing are the odds of success or the odds of failure here. So when you're looking at the variables, how this would work is you would hold all other variables stagnant while changing or looking at the odds of success for one specific variable. So the important thing here is, as we're looking at ticket fare. So if we were to hold all other odds or all other variables stagnant, the odds of surviving, if you were to have a 1% increase in survivability, would go up by 11 here. So that's just kind of like an example, and this is a simple one because on the next I'll show the full Titanic model, and then we'll talk a little bit about that as well. So here's the full Titanic model. It's kind of long, and you guys can look at that and just kind of briefly look. So we do have interaction terms there between traveling alone and age, traveling alone and ticket fare, and then gender and ticket fare as well. So it's, like I said, it's very similar to a generalized linear model, or to a multiple linear regression model, and how you build it. Like I said, the logit function is really the only thing that'll change it. So at the end, our odds of success or failure will be between 0 and 1 there. And so here's some output for jump, just to kind of show similarities, but also show some of the differences, so you can kind of understand some of the things that are going on here. So the red box up there, that is still explaining what the most important predictors are in predicting whether or not a person would have survived or not. So looking at it, gender is the most important thing to say whether or not somebody survived on the Titanic. I believe females were the most likely to survive, and if I remember correctly, it's because a lot of them were workers at the time, and so they had the best chance due to the fact that they were in some of the higher class places on the ferry there, followed by like ticket fare and then interaction between gender and age. And I believe this here is talking about the odds as well, this blue square here. Where it's talking if you're, like I said, to hold all of the other variables stagnant and you were to look at the odds of one, so like if we were to hold the age, gender, age, and the rest of them, and then look specifically at gender, you have your odds would go up by 255 as a woman, in your chances of survival there. So that's just kind of some of the explanation of the logistic regression model. Like I said, the big thing here is that you're able to look at a binary outcome, whether or not success or failure, and you can use this for any other type of generalized thing of that nature. So this was just a quick example using the Titanic just because we've all looked at it, we kind of understand it. You guys know the background of something easy there. So